So here we're going to cover scatter charts and trend line. The video is divided by different parts, so you can just jump to whatever area or topic you want to look into in detail. Now that we have our data transferred to Excel, we are going to create a scatter chart. Why scatter chart among the many options that Excel offer? Well, scatter charts show relationship among numeric values in several data series, or you can plot two groups of number as one series of XY coordinates. And this is really, really important for handling scientific statistics and engineering data. We typically want to see relationship between two sets of physical variables, right? And the relationship between them. We will do the scatter graph and we're going to get the relationship adding a trend line and looking for a equation that relate both variables in in a relationship. So in terms of the table, another hint that I can provide you, again, students like to, make the table look pretty. So what you can do is just centralize everything here. And here you can just add, how you call it, borders to this. If you click here, you see, there's all borders. And now you have your data to look pretty. So let's start by creating our data, our scatter graph, I'm sorry. Um, in terms of the data that we're going to select, what I'm going to do, I don't know if you notice, we don't have the typical one column for X and the second column for Y because we have a couple of trials, we have an average. What we have to keep in mind is that we're going to graph temperature. Okay, I'm going to just highlight this, and the average of the solubility. Copy, paste, so I know that my average, right, the real physical variable is solubility of water. So solubility of sucrose, I'm sorry, in water. So with that in mind, what I'm going to do is I'm going to insert a chart. You can go here all the time on the top, or now you have these cool shortcuts that Excel has, these inside tabs. As you may see, there's different type of graphs. I'm gonna pick scattered. Between all the scatters, I don't want to have lines because the line, right, the relationship between the two variables will be provided by the trend line, and we're going to do that after we create our chart. So we just want to see the dots graphed. And if you see there's a mess, right? You don't know, Excel doesn't know what you want to graph, so it just throw this to you. So the best way to manage any problem with data is just to get used to the environment here of the uh, chart. If you click this, what it's going to do is that it's going to highlight the plotted area. If you click here, you're going to be handling your legend. And if you click back here, I don't know, here you see you are clicking the grids, right, of the table. You can just delete them if you don't want them, or just undo it to show it later. We're gonna manage this later in another video, how to format your graph. In terms of the data, if you click here, you see you're highlighting the data. You can just see exactly what is being highlighted. It's very hard to see what you have here because it's just a mess. So I'm going to right click the data point. I'm going to left click, right? This I have a Mac, so I don't have a right or left. Just it's pretty much the same. So if you left click the data point and then you select data, okay, what you're gonna see is all these series. Series are called the lines, right? The relationships that you want to create. We just want to have one series, and that series is the X will be temperature and the Y will be the average of the solubility values. So you see there's a lot of things going on here. You just remove, and remove, and at the same time, I don't know if you notice that the table becomes more cleaner. So what I want to do is I want to name that series. It's going to be solubility. Cross, if you want to have just a name. Uh, X values, what I'm going to do is that I'm going to come here. You see, I'm going to delete this to make sure I'm just picking the correct data point. You're going to touch the cell and you see here equal to, you're going to touch the cell and drag down, right? Hold, I'm going to go back. Touch the cell, drag down. Okay, and like that, you're picking your X values. You're going to do the same thing with your Y. You're going to come here, you're going to erase. And I don't know if you notice, because Excel doesn't know what you want, it just pick randomly the column that is close to temperature. So I'm going to erase that, drag, and now I have my data, okay? So if you see, those are my data points, okay? The graph doesn't look like super pretty, but we're gonna handle that in a moment. Um, so because I only have one data series, I don't really need the label for this because the name of the graph will show the title for that specific series. However, this becomes really important when you are handling multiple series, and that will be shown in another video. So let's delete this. And what I did is just touch the legend and delete it. As you may see, this is the data, graph data for our solubility. I'm very curious to see what's going on with this point. You see, it doesn't make the line. I'm gonna come here and try to look that to that point, and it seems that is the, if you look at it, it says 23, meaning that 23 degrees we have a record solubility of 2.01, right? I go to my graph, and well, yes, because it seems that we have here an outlier, right? Is a problem in our data, but you know what, is our data. We don't handle and we don't mess up with that. That's our experiment. We have to stick to it, or do a statistical analysis to see if we can remove it, but that is out of the scope of this video. So as you can see, the table has the data, but it's not complete. Every table needs to have a title, the name of the axis, and the correct interval or scale in their axis. So if you can see here, there's different options in the Sharp Quick layouts. You can click one of those, and what it's going to do is going to start changing. You see here you added the axis and the titles and the legend. You have here different formats. It will depend on your requirements in your class or your publication or your report. In my class, however, I do want to see the axis and the title and the title of the graph. Again, I only, you only need to show the name of the series if you have more than one series to be graphed, but in this case, just to make it cleaner, we only have one series, and we're gonna leave it like this. So let's start with the name, right? Solubility of sucrose, name of the title of the graph. Solubility of sucrose in water at different temperatures. Okay. So remember that the title of the graph have to show exactly, the independent and dependent variables, and it has to be very clear about that. I want to say that you can format your graph. You see the size of it, however you want to do it. You can also add the graph to a whole page that you can see it. However, I like to see my graph close to the data in case I need to add more data into it. So the titles axis here, you can just do this, copy, paste, right? Or you can write it down if you want. Okay, and then here, temperature. Come on. You can double click and then you paste it there. You can even move this lower or farther away from the label of the axis. And okay, so you have everything that you need. However, if you notice your graph kind of shift to the right, so maybe a better range of data point will be from 15 to maybe 30 degrees temperature. To do so, what you're going to do is you're going to click here, your axis. You see that everything is highlighted. You can just do right click, right? I want to point out that I'm very used to the right click in my Excel because of the old versions. I came from the old school. So the new version have here, you see formatting, chart layout. You see you can start adding stuff into it. Whatever you feel comfortable with, you can play with the um, here with the shortcuts, or you can just right click like I do. So format axis, okay, and then you're gonna see a pop-up of a window here. And in terms of the scale, right? The scale, we want to change the scale. The minimum scale wanna be is 15, and you see that your data is better spread and you can see it more clear. And my maximum, I want it to be 30. Okay, you can do that, or you can just leave it at 27 like they suggested. It doesn't matter. You have to, the only thing you have to make sure is that your data is within the range. How do you know that? Well, you come here to your data and see the range, right, that your data lay on it. The major unit and minor unit are the subdivisions, okay? So if you want more detail about this, let's say that instead of going by twos, I want my data to go by ones. And now you see, it's more detailed. And let's say if I want my minor unit to be by point 0.1, I can do that too. However, my minor unit is not shown because I don't have the thick marks for that. And the thick marks are just the lines, right? That lines on the axis that tells you the where the numbers lie on. So right now, if you go here from scale to thicks, you see that major thick mark type, there's nothing. And you have a couple of options. You can have it inside, outside. I'm just gonna do it across the axis. The minor thick is not shown either. So if you want to have it too, you can just do this. Typically, you can just do the cross this one and maybe in the inside the minor one, so it's clear which one is the minor thick marks and which one are the major uh, thick marks. So in terms of the thick marks, we're fine. You can also change the font type, get it, creative with it. You can change the fill line if you want a more, uh, you know, bold or not. I'm okay with this. This looks perfectly fine. In terms of the size of the font, I don't know if you can notice that if you make this bigger, just for the resolution of the table. Okay, you can just come here and uh, it's 10 the font size. You can just make it bigger to 12, which is typically the same size of the when you write it down. You can play with this. 12 is fine. Just try to stick with a size that allows you to see clear the graph when you copy paste it to your report. 14, whatever. Um, so I think we're done with this part. We're gonna now do the trend line. I want to point out that I did the y-axis. Here you can do exactly as the x-axis and format just to look good. I want to also say that you can change the division or gridness, right? In the graph, that's up to you and the formatting that you want to pick for your report. Okay, so for the trend line, what we're going to do is that a trend line, let's define what is a trend line, right? Our trend line is just a line, right, that describe the relationship between the two variables. Like any line, okay, or any curve, it has an equation. You can describe not only graphically, but you can also use an equation to describe it. And the good thing about having a trend line or that equation is that you don't need to look at the graph. You just need to plug in the data and get the information at any other condition, right? That is not specified by the graph. So let's start. Again, you can go through your tools on here on the top. I like my right click, okay? So I'm gonna go here to I'm gonna select the right click. I'm gonna add trend line. And as you see, the computer just generate the type of the line that better describe the data points. Here you can have at the left different options. Okay, logarithm, polynomial. So it will depend on the analysis you're making. Typically, if you don't know what should be the relationship, you try to get the best fit to the actual data points, okay? But our relationship is linear. We know that there is a direct relationship between temperature and solubility, and that relationship is linear. So any deviation from the linearity of that line is due to, like this point, right? Is due to our experiment, how we did the experiment. So we picked the line. There's something called options, and in options you can actually ask the software to display the equation, okay, on the graph, and something called the R square, okay. Okay, it is done. There's also here something called set intercept to 0. We don't want to force that to 0 because our data points are experimental, so they do have a trend, and any deviation from 0 could be just because of the physical parameters or because of the equipment that we're using to measure the data. Okay, so I'm gonna just set here, okay. This equation can be moved around. It's cool, right? You can just move it around in the case that you have multiple series and you want to see the equation displayed. I'm going to show you later in how to do the stackable graphs. But at this point, I want you to look at this equation, right? You have to understand that y and x are mathematical symbols, but in terms of the science, y has a meaning. In this case, is the solubility, and x is the temperature. So we have a direct relationship, right? There is a constant here between y and x, solubility and temperature, but there's some deviation to that, and that is probably because of the data point. This is the intercept, right, on the y-axis. So how is that deviation from the real behavior or the linear behavior of our trend line? R square is a statistical calculation that helps us to understand that. The better the data fits the linear equation, the closer to 1 the R square will be. So if we do again the experiments and it turns out that we get an equation where R square equals to 0.99, 999, that one is a better experiment than this one. So this will come very handy when we use it later in other experiments to see which graph better describe the data point. So for now, this is just equation. This is how you should be doing the experiment, the simple linear plot with a series of data point. I hope that you enjoy the video.